Okay, so I'm gonna go over titration of strong acid, strong base again. Okay, so you have to remember to titration strong acid, strong base. They're really easy. You're just basically using the concentration of acid as a H plus and concentration of base as a OH minus. The only difference is in a base, sometimes that could be 2 times. So what I'm saying is if you're looking at, let's say CaOH2, right? That would be a 1 CaOH2 has 2 OH minus. So that would be 1 to 2 ratios. That's the only one that you have to worry about. Okay. All right, let's get started. So find the initial pH of the solutions and tell me whether it is weak or strong. Okay, so you should know that initially you will have this in a beaker, which is HCl, which is in this case is a strong acid. So since it's strong acids, concentration of HCl is basically equal to concentration of H plus. In this case, that would be 0.800 molarity. Finding pH, that's really easy. You have to remember the formula. pH is equal to negative log of H plus. So you just basically do a negative log of 0.8 and then you're gonna get your answers. Next is said you're gonna add the KOH and then tell me what happened. All right, to figure out what happened when you add KOH, what we're gonna do is this. To find what happened when you add a KOH, let me just kind of change these. There's a lot of stuff on the screen. All right, so to find it, you first have to figure out concentration of initial solution. So in this case, this guy. So that's why I said find the mole of H plus. So we're gonna find the mole of H plus, which is 0.8. Molarity just means mole over liter time liter. Notice that it's a milliliter. That means 0.1 liter. So therefore, you're gonna get 0.08 mole. That's my H plus. Find the mole of OH minus added, well, which is right here. That's the one that we're gonna use. So 0.25 liter, right? 0.25 liter. It's gonna be timed by 0.2 mole per liter. So that's gonna give you 0.25.2. That's gonna be 5. So 0.05 mole of OH minus. Okay, so what's gonna happen next? What's gonna happen next is find the leftover. Always, you're subtracting it. Make sure you're subtracting it so that you get the positive value, not the negative value. Okay, so in this case, leftover is gonna be 0.03 mole of H plus. Find the concentration. That means divide that by the total volume. Total volume is going to be 0.25 liter plus 0.1 liter, right? This one and then this one added. So then we're going to say this is divided by 0.03 got divided by 0.35. So we're going to get 0.0857 molarity. Since this molarity is a concentration of H plus, you can just find pOH by doing negative log of the answers. Now I'm going to get my pH as 1.07. Okay, so that's the difference. Okay, so we get that. Now notice that my pH has changed from up here. Oh, I didn't do that one. Negative log of 0.8. So that would be a 0.097 to that. So my pH has went up a little bit. Let's continue. So how much volume is needed to get to the equivalent point? Easy. You want to find first initial mole H plus in the solution, which we have done it up there. So I'm just going to rewrite it. Okay. And then more OH minus needed. That's going to be the same number. Okay. And then now use a concentration to find the volume. Easy. The concentration of OH minus up there is a 0.200 molarity of KOH, which just means 0.200 molarity of OH minus, right? So that's what you're gonna have. You move up. So molarity, mole per liter, right? So 0.08 mole times liter mole 0.2. That's gonna give you. You can actually do this without calculator. Move one over, move one over. So that 0.8 divided by 2, 0.4 liter. Okay, 0.4 liter, or you can say 400 milliliter. Makes sense. What is a pH at equilibrium point? For the strong acid, strong base is always 7. Okay? Granted that it's a 25 degrees Celsius, of course. Right? Unless they say otherwise, it's 7. All right. pH, this, first find the mole. Again, initial mole, we already know. I'm just going to rewrite it. If not, you should refine it. Mole OH added, let's do that. That's a new number. Should be 0.550 liter times 0.2. That's a mole over liter. So 0.2 times 0.55. That's going to give you 0.11. That's going to be mole OH minus. Okay, so you can see the leftover. You have more of this. So we're going to have more of this, 0.03 mole of OH minus. Okay, how do I get that number? I subtract these two. Okay, so that means I just did 0.11 minus 0.08, if you're wondering. All right, find the concentration. Easy, 0.03 mole divided by liter. Liter, what did we add it? We add 0.55 liter plus original amount 0.1. Those are liter equal to divided by 0.65. So we're gonna get 0.046. That's a molarity. Be careful what is a molarity of. This is a OH minus because that's the excess. Okay, if you're wondering, all right, excess. Okay, so since you have OH minus, what you're gonna do is you need to convert that OH minus into pH. All right, so you're gonna do negative log of OH minus. That's gonna give you POH. pH equal to 14 minus POH. I'm not gonna do the plug it in. I'm just gonna plug in the calculator. Okay. So I'm gonna get 12.66. That's gonna be my answer. All right. That's a strong acid, strong base. Hopefully that helped. I'm not gonna do the next two. The next two I'm gonna ask you to do it. I kind of give you step by step. The only thing I'm telling you is this. Every time you see this, notice that concentration of CaOH2, right? 2 of that. You got to times it by 2. And that will be equal to concentration of OH minus. Okay? Because each one of this will broke into 2 of this. So that means concentration of this is 2 times of this concentration. So make sure you're aware of that. That's the only thing that's tricky. Other than that, you should know how to do this. Okay? Same thing. The next one is the same thing. It's a 2-1 that you have to be careful about. Okay? It's a strong acid, strong base. All right, weak acid, strong base. Okay, weak is a little bit confusing. By the way, we will always put the strong one in the burette because that make it our calculation easier. So that's what they are doing. Okay, that's how the titration gonna work out. Can you have a weak acid, weak base? Yes, you can, but it's a little bit harder to calculate. And for the APs question, we don't see them. So we just gonna need to know strong acid, strong base, weak acid, strong base, weak base, strong acid. Okay, so let's get started. Initial pH, how to find it. For the weak one, you always have to do ice. So we're gonna do the ice dissociation thing. So write the dissociation. So HF, H plus F minus, HF concentration 0.8. That's what it said. Initials, change, equilibrium, nothing here. Minus x plus x plus x, 0.8 minus x, x. Again, Ka small, so we're going to assume 0.8 minus x is approximately 0.8. Okay, so that's what we're going to do. So therefore, Ka equal to concentration of H plus. Remember, product over reactant. Okay, bracket. Don't forget that. All right, let's plug it in. 6.6 times 10 to the negative 14 equal to x divided by 0.8. You're gonna solve for x. Okay, so I have no room. I'm gonna do it here. I'm gonna carry on this way. All right, so what we're gonna do is I'm solving for x, so 6.6 times 10 to the negative 4 times 0.8. Don't forget the square root so that you found x. So in this case, we got x to be 0.022, I would say 98. I do notice I put picking a lot. I should probably round it in 3 suffix and you will probably get 0.0230. Okay. Anyway, this is the molarity of the H plus. Okay, the same thing. You know, because that's the X, right? That's the X. All right, so now that you have this, you're gonna find the pH. Easy, right? Negative log. So we're gonna get 1.64. Okay. Decimals. Technically, I use 2 suffix right here, 2 suffix. So I'm using 2 decimal. Okay. All right, let's continue. To do the next one, you're gonna have to find mole just like the usual. So that's mole of OH minus added. Right here is a mole of H plus or HF, not H plus, HF. Okay, so that would be 0.1 liter times 0.8 mole per liter, 0.08. Okay, mole HF. Right here, 0.25 times 0.2. So that would be 0.05. Right, that's the mole of KOH, which is equal to OH minus concentration. Okay, again, if you have H2, not H2, sorry, SrOH2, then that would be time 2. But in this case, it's just KOH, so 1 to 1. All right. Okay, so now what happens, you got to subtract these to figure out how much HF and how much F minus. So you will notice that OH will neutralize HF. So you're going to have to use up 0.05 of them and leave me with 0.03 mole to be HF, and then 0.05 mole of F minus is going to make. Okay, think about that. That's what is used. All right, fine, ice. You're going to write the Ka. HF, H plus, F minus, plug in 0.03. Now, notice that you have a mole. So I'm going to convert it to molarity actually. So I'm going to change it to molarity. Okay. So it's a little bit easier to do it here. So I'm going to do molarity first, and then I'm going to plug in molarity number. So that means 0.03 divided by, well, we have 100 milliliter, 250 milliliter. So that means that's 0.35 liter. Okay. Same thing here, 0.05, that's still 0.35. That's going to give us molarity. So let's try that. 0.03, 0.35. I'm going to get 0.0857, 0.05, 0.35. So 0.143. Okay. So let's plug it in. 0.0857, nothing. 0.143. Initial change equilibrium minus x plus x plus x. This is 0.0857 minus x, x 0.143 plus x. Okay. Again, on the test, if you needed to write it like in left, right, or squish them in because you don't have enough room, make a break, boxes, so that they can at least tell where is you going. Be helpful to the grader to be able to figure out what's going on. So I'm going to continue on here. I'm not going to write the formula. You should know. Okay, so Ka 6.6 times 10 to the negative 4. Product over reactant. Again, I'm going to say assumption part. You do need to write it down, assumption part, on the test. So what you're gonna do is you're gonna say Ka is small, so that this is approximately equal to this. This is approximately equal to this. Okay, so that's what is happening. So this one is gonna be 0.143. This is x. This is 0.0857. Now right here, you could do Henderson-Haxabout equation if you want after you get to this, because what happened, you find a concentration of acid and you find a concentration of conjugate base. So you could do Henderson-Haxabout equation. Here, I'm just choosing to solve it normally. So that's what we're doing, okay? So that's what we have. And then let's see what happened. So multiply, divide, right? Solve for x. So concentration of H plus is basically the same thing as x because that's the H plus. Okay. Again, you can do Henderson-Haxabout from here right away when you get to that number. That's the same thing. All right, so I'm gonna do the calculation. 6.6 10 to the negative 4 times 0.0857 0.143. Of course, we're dividing. So we're gonna get 3.955, so 6 times 10 to the negative 4. Don't forget molarity. pH, use this to find pH. Negative log, 3.40. Okay, so if you look at this, you see that your pH is going up, which makes sense because you're adding base to it, so your pH is going up. Right, becoming basic slowly. Not yet. It's still acid though. All right, let's continue. Find the mole of H. Same thing. So we're still doing the usual. So mole of HF or moles of weak acid. So this is 0.08 mole of HF. Didn't change. I didn't change anything. Right, it's still the same. More OH minus needed. That's gonna be stayed the same. Find the user concentration to find the volume. So concentration of KOH is 0.2, so we're gonna use that one. Okay, so 1 liter, 0.2 mole. So again, you can do the math like this. So you would notice that 0.8 divided by 2, so that's 0.4 liter. Or you can say 400 milliliter. Same thing. All right, let's continue. Move it over. What is the pH of the solution at equivalent point? This one is a little bit difficult. You can't just say 7. You got to have to figure out. So what happened at equivalent point? You need to know that all weak acid is non-conjugate base. So you no longer have HF. You only have F minus. Okay, so that means you're writing F minus equation, so to speak. F minus is a conjugate base. So that means it's going to add like base. It's going to strip the H back. Okay, so where's that H come from? From the water. Okay, so that means this is going to be now OH minus. All right, so this is now this amount, ICE again, this is now our thing. So 0, 8, nothing yet. Change, obviously minus x plus 8, 0.08 minus x, and an x. Okay, now notice that this is the, mole, right? So we're writing, this is the mole that we're writing. You do need to write the concentration, not mole. So what you need to do is you need to change it. So in this case, what's going to happen, because when you're doing Ka, you're using the concentration, not the mole. So you got to change it. So that's the tricky part. Make sure you always do that. So you're not going to really write 0.8 or 0.08. So 0.08 is a mole. You got to divide it by volume. So we do know volume because we know that originally you have 100 milliliters, so that's mean 0.1. To get to the equivalent point, you had to use 400, so 0.4. Okay, so that means you're gonna use 0.5 total. 0.5 liter with a 0.08. So we're gonna figure that one out. That gonna give you molarity. So that is 0.16. Okay. So for that reason right here, when you're doing this, I would erase it and I would use 0.16 instead. So hold on a second. Okay, so let's do that. I will go ahead and use that number. So 0.16, 0.16. Okay, so that's what is going to happen. So now next is we're going to find out. Notice that we are having KB. So you do need to use the base number. So KB is 10 to the negative 14, or KW divided by KA, which is given earlier as 6.6 times 10 to the negative 4. Okay, which is obviously really, really small, so you can assume this to be 0.16. Okay, so that means this is x 0.16. You're gonna solve this. So when you get an x, you're basically getting concentration OH minus. Beware of that, because that will give you POH, and then from there you're gonna get the pH. Okay, so let's go ahead and solve these. All right, so 10 to the negative 14 divided by, shifting, 6.6 times 10 to the negative 4. Okay, hold on, it is moving. Okay, so that's what we're gonna have, and then we're gonna do multiply by 0.16, sorry, 0.16, and then square root to find x. So we're gonna get that at 1.557 times 10 to the negative 246, negative 6. Don't forget molarity. I'm gonna take a negative log of that. That is my POH. Don't forget that, it's not pH yet. Not until you do 14 minus, and then you got 8.19. That's my pH. Okay, so which is makes sense. What happened? You're titrating a weak acid with a strong base, so your pH is greater than 7, which makes sense because at this point all you have is conjugate base. Okay, let's continue. E. What happened when we overshoot it? Idea is the same thing. How you gonna do it? Okay, so your pH. Find the pH when this liter molarity is added to this. Same thing, I need to figure out how many am I adding. So 1.1 liter times 0.2, okay? That means 0.22 mole of OH minus is being added. This part is the same thing still. That's giving you 0.08 mole of HF. So obviously you're adding a lot of extra. So we're gonna figure out what is the leftover. So 0.22 minus 0.08, we're gonna get 0.14. Okay, 0.14. This is gonna be more leftover. So whoever one is bigger. So in this case, OH minus. This is gonna be where your base is. Okay, so we said strong base. That means this is it. You're not gonna use this guy. True, there's gonna be some conjugate base, but it's negligible. We're not gonna care. We're only gonna care this guy. Okay, to find pH, you just basically do concentration of that. So find the concentration, right? So you get mole. Don't forget to find the concentration. So concentration 0.14 mole divided by, let's find the liter. 100 milliliter, 1.1, that means 1.2 liter. Okay, so 1.2, that's gonna give you 0.11666, and then keep going forever. Molarity, this is a concentration of OH minus. Don't forget that. pH, negative log, and then minus 14, so that we can 14 minus, right? So that you get pH 13.0669, so 7. Okay, that's what we get, which makes sense. It's getting more basic and basic because you're adding more base. All right, hopefully that makes sense. Now I'm going to do backward. So we're going to do weak base with a strong acid. So same idea. We just flip it. Instead of weak acid, strong base, we got weak base, strong acid. So let's take a look. I kind of keep these on purpose. I didn't really refix it, type it. I did it on purpose. So I want you guys to see what's the difference between the last calculation and this calculation. So in this calculation, all we are doing is using this number, right? Or this thing to figure out. So we're still using this. So write the dissociation equation for the weak base, because that's your initials, right? That's what you're gonna have in your beaker, and you're titrating with this. Okay, that's the one. So this is NH3, right? So that means base. Do you see that? Weak base. All right, so NH3, since it's a weak base, I am gonna choose to use water to help out writing this. It's gonna grab the H, NH4 plus, that's a conjugate acid, right? And then OH minus, of course. ICE, initials, 0.500. Notice we don't care about HBr, not yet, because you haven't added anything yet. Your beaker or your flask only have this. You haven't dropped anything from burette yet, okay? Notice we're using molarity. Nothing, nothing. Minus X plus X plus X. 0.5 minus X, X, X. Again, KB is small. So that means 0.5 minus X is approximately just 0.5. Okay, we're gonna use KB. Why do we use KB? This is base equation. Okay, so you gotta use a KB. Okay, find the concentration of H plus and then find the concentration of OH minus. We're not gonna get H plus. What we're gonna find is we're gonna find the OH minus first, and then we need to use this to find the POH, and then we'll find the pH. Okay, so that's what we have to do. You're not gonna get H plus, you're gonna get OH minus. Make sure you're aware of that. Okay, so KB equation. I'm gonna continue on this side. So 1.8 times, again, I'm going to omit a little bit of writing formula in this case because we have done it in the last question. So I am skipping. If you need to pause and go back to look at the other question, please do so. Okay. This is a video recording, so I do tend to go a little bit faster. If you need to slow down, you can. All right. Multiply. Don't forget a square root. We're gonna get 0.003. Don't forget the unit molarity. Now, find the POH and then find the pH. So I'm gonna skip step, like I said. Okay, simply you're doing negative log and then you're doing 14 minus. So we're gonna get at 11.477. So I'm gonna choose to use 48. All right, next one. pH of this when this is added. Okay, now notice you're doing initial. Initial is base, so you're finding initial concentration, initial mole. This one, do this first. So that will give you 0.05 mole. Okay, this is NH3. It's a base. OH minus, it's not OH minus, now we're adding H plus. It is coming from this. Okay, so that's gonna give you 0.025. Okay, 0.025, and then this is a mole of H plus. Now you need to know how much is left. Now, not HF or F minus, those are different now. You're doing NH3, so that means you're talking about NH3 or the NH4 plus. Okay, and then after, we're not adding strong base, we're adding strong acid. So again, the difference between the two questions, right? This is the last question. There is some difference. So how we're gonna do it? We need to figure out how much you have. In this case, you use halfway, right? Exactly halfway, because you have 0.5, I use it 0.25, 0.025, so you're gonna have 0.025 left. This is 0.025, this is 0.025. Something magical happening right now. This is a mole, this is a mole. Your amount is the same, okay? I'm gonna divide it by liter, 0.2. Why? 100, 100, that's a 200 milliliter, 0.2 liter. Okay, that means each one is 0.125 molarity. Okay, you can use the eyes to find a pH. In this case, I'm gonna do shortcut. In the multiple choice case and stuff like that, you gotta be clever. If you have concentration of weak base, which is equal to concentration of conjugate acid, or if you have a weak acid and a conjugate base that are the same, that means you can simply say pH is equal to pKa. So you're going to do negative log of Ka. That's what you're going to get. Okay. Now, obviously in this case, you have a little bit difficulty to do. You don't have a Ka, you have a Kb. So you're going to need to figure out Kb value to Ka value. So 10 to the negative 14 divided by KB. Okay. So I'm going to get this at 9.255. So I'm going to use 9.26. Look, your pH is dropping, which makes sense. We're adding acid, so your pH should be dropping. Okay. Now, you can use ice like the last question to find it. It's still going to be the same thing. I just do a little shortcut. Okay. All right, let's continue on. Again, we're now finding the HF. This is NH3 in this case. Initial, we do have it up there. I'm going to just reuse it. Okay, how much is needed is still going to be 0.05 because this is the amount of H plus needed to neutralize the mole NH3. Using that mole to find a concentration of H plus needed, or HCl or HBr needed. So what you're going to do, 0.05 mole concentration up there, 0.25 molarity, so mole liter. We're going to get and have 4 times this, 0.2, 0.22. Wait, no, that should be 0.2. Yeah. Okay, that's how much you need, 0.2 liter. All right, let's continue. Where's that pH at equivalent point? Again, at equivalent point, all the weak base is converted to conjugate acid. All of the NH3 is now NH4 plus. So we're gonna need to write the NH4 plus equation, right? So what is gonna happen? NH4 plus. By the way, I'm gonna do the ice table on this side, so a little bit easier where I write the equation. Okay, I'm gonna say water. Okay. It's still recording. Okay. It is gonna make NH3 plus, right? Give it to this one, H3O plus. Or you can just say or you can just simply say NH4 plus is gonna become NH3 with the H plus. That work too, the same way. Ice now. Okay, before you do the ice, I'm gonna need you to go back and take a look at the amount. So amount is gonna be this, 0.05 mole. Okay, that's how much is needed. So it is 0.05 mole. But your concentration is not the same, right? That's the mole, but that's not the concentration. So you gotta divide it by volume that needed. The volume that needed to use is 0.2 plus the volume that was initial, 100, so 0.1 liter. Okay, so 0.05 divided by 0.3, 0.1666, or just say 7 molarity. So I'm going to use 0.167 molarity, nothing, minus x plus x plus x, 0.167 minus x, again approximating 0.167. So I'm going to come to this side. Okay, this time you have an acid equation. You got to use Ka, which means not really the other number. You're going to do 10 to the negative 14 divided by Kb value, which is 1.8, 10 to the negative 5. So you're going to have 5.55 times 10 to the negative 10, which is x 1.167. Square root that. X is equal to 9.6 times 10 to the 2, 4, 6, negative 6 molarity. Note what your X represents. In this case, H plus. So finding pH, easy. Negative log. 5.02. Notice your pH is getting down and down because you're adding a strong acid. Okay. Now we're gonna overshoot it. What's gonna happen? Same thing. Find the mole first initial, which is in this case NH3. That's where in the solution right here we have done it. This is 0.05 mole of OH minus added, not OH minus, in this case HBr, so that means that's an H plus. Okay, so that would be 0.3 times 0.25, so 0.075 mole of H plus. This is NH3. So who is bigger? Well, obviously this is bigger. So you're going to have that minus 0.05. We're going to see 0.025 mole of H plus is an extra, okay, leftover excess. Since your strong acid is instead, you're just going to find the strong acid's concentration. 0.025 is mole divided by liter, 0.1 liter, right, 100 milliliter, 300, so 0.3. So that's divided by 0.4, 0.0625 molarity. By the way, this is H plus. So pH negative log 1.20. That's it. That's how you do strong acids, strong base, weak acids, strong base, weak base, strong acid titration. Your jobs, do these other two and also the other two that I didn't do.